Dear students, I welcome you all to the lecture series of Basic Civil Engineering. Today we are going to discuss on 2 points: load acting on building and load bearing structure and frame structure. So this point is taken from the topic building design. On second slide, we will discuss the point about loads acting on building. Here there are several different types of load: dead load, live load, wind load, snow load and seismic load. Here first of all we will see what do you mean by load. Load means anything which exerts pressure on a structure is called as load. So whenever you are going to construct any type of a building, all these different types of loads will exert pressure on a structural component of a building. Here structural component means like wall, column, slab, beam. Now this dead load, live load, wind load, snow load or seismic load, all these different types of loads will exert pressure on the structural component, and this structural component should be able to bear these different types of loads. Now we will see the third slide. On the third slide, the point is dead load. So what is this dead load? Dead load means it is a permanent, immovable and untransferable load of a structure. Now to construct a building we require different types of material. For example, let us take if we want to construct a wall. So the material required is the brick. So this material brick will have its own unit weight, and the unit weight of a brick is 22 kilonewton per meter cube. So to construct a wall we will require this material brick. So as we construct a wall, now this wall will have its own self weight, and that is a permanent, because this wall is immovable or it is untransferable. So the dead load of any such part can be calculated by multiplying its volume by unit weight of the material. So you can see in this table, in that different materials are given and their unit weights are given. Now if the brick masonry wall is of 10 cm thick, you can take the unit weight as 192 kg per meter cube. Live load. Live load is the movable, temporary and transferable load on the floor. In a building, the example of live load can be taken as the weight of the occupants. furniture, equipment and machinery. Now, the occupants or the machinery can be transferred from one place to the other. Therefore, it is called as movable or transferable load. These live loads are assumed to be acted uniformly over the whole floor area, and the total live load is proportionately distributed on the wall foundation. Now, as you can see in the table, types of building and minimum live load are given. So, for dwelling house, the live load on floor minimum should be 200. Wind load. In case of tall building, the effect of wind pressure is considered. Now, as you can see on this slide, the diagram of a tall building. Now, on this tall building, the effect of wind pressure is shown by the blue color arrow marks. Now, this effect of wind pressure is on the external faces of the tall building, that are the walls or the sloping roofs. So, this effect of wind pressure reduces the pressure on the foundation, on the windward side. For the purpose of design, it is assumed that wind load always acts horizontally over the entire exposed surface area, that is your wall or the roofing surface. So it is given by the equation P equal to kV square, where P is the wind pressure in kilonewton per meter square, V is the wind velocity in kilonewton per meter square, and K is the coefficient which depends upon the type of the factor, such as wind speed, temperature of air, shape of structure. Snow load. As you can see in the diagram, the load of the snow acts on the roof. The actual load due to snow will depend upon the shape of the roof as well as the capacity to retain the snow on the roof. The design of the roof should be such that it can bear the load due to snow. Mountainous regions in northern parts of India are subjected to snowfall. Load of snow may be taken as 2.5 kg per meter square per centimeter depth of snow. Seismic load. Earthquake causes shaking of the ground. So the building resting on the ground will experience the motion. Due to earthquake, the vibration of a structure can be resolved in any three mutually perpendicular directions. The direction of ground vibration is usually horizontal. The engineering intention is to make the building strong to resist the effect of ground shaking, although they might get damaged but will not collapse during the strong earthquake. For safety of people, content is assured in earthquake resistant buildings. Now we will see the slide that is based on structure. Now to construct a superstructure, you will use three different methods. As you can see, first one is the load bearing structure, second one is frame structure, and third one is composite structure. Now these three methods will be used depending upon the choice and the extent of construction. Now, how much number of stories will be required to construct and how much area is covered? Then, importance of construction, whether you want to build residential or industrial. Third will be your economy, means you want to build a low cost housing, middle class or high class housing. And the last will be the type of land. It will depend upon the bearing capacity consideration. Load bearing structure. Now on this slide you can see two diagrams are present here. One is the construction of a two-story building, or you can say a house, and this is a frame structure. Now in both the pictures what you can see will be the roof. This is a wall which is made up of bricks. This is a slab and this is the foundation. Here also you can see this is a roof. This is a load bearing wall where you can see here it is made up of brick, the construction, and this is a frame. Okay, so here you can see this is a load bearing wall, this is the slab, this is the soil, and this is the footing. It is the foundation which is made up of concrete. So such type of structures are more suited where hard strata of soil is available at shallow depth. Brick foundation needs larger foundation area. With respect to RCC frame structure, because load bearing capacity of brick is much less than that of RCC. Most of residential buildings are small in size and are up to 3 stories, are constructed as load bearing structure. Now in this diagram you can see this is a 2-story construction. Now we'll go to the advantages of load bearing structure. It has thick brick wall, as the construction is made up of brick, so it is a thick brick wall. Thicker walls give more weather resistance and noise protection. It is good and cheap for less than 2-floor construction because the bricks are cheap. Disadvantages: it loses carpet area due to more thickness of wall. Labor work is increased and material like brick is also required in huge quantity. When the wall will collapse in any situation, the whole structure will collapse. Load bearing structure is bad at earthquake resistance, as shock wave produce irregular tension and compression in columns. Tension is bared greatly by steel of RCC, which is absent in load bearing structure. Here you can't see any use of steel in this construction. Therefore, it cannot bear the tension. Now on this slide you can see the different pictures of load bearing construction. So all these are different load bearing structures. Frame structure. Now we will understand what do you mean by frame structure. Now this is a structure comprising of slabs which are resting on beams, and beams are supported by the network of columns. Now you can see there is the image of the frame structure. So this frame structure consists of slab, beam, column and the foundation. This frame structure can be of concrete, steel or of wood. The load from the slab are transferred to the beams, and this beam rests over the column, and whole load of the structure is transferred to the subsoil below the ground through columns and the footings. Here walls just act like partitions and none of them bears the load. Reinforced cement concrete is the most suitable material to withstand the external loads like compressive, tensile. So all these frame structures are constructed with reinforced cement concrete. All the multi-storied buildings or high-rise buildings are constructed as frame structures. Advantages: they are flexible and they have good results in earthquake. Cost reduction due to thinner walls. Speed of construction, can add more number of floors. Carpet area is almost same. Disadvantage: the disadvantage lies in between different types of frame structure such as concrete structure, steel structure and wood structure. Now on this slide, the different pictures you can see, these all are made up of RCC. So all these are the frame structures. Composite structure. On this slide you can see the diagram. Now this diagram is the structure which is constructed with the combination of both, that is the load bearing as well as frame structure. Therefore this structure is called as the composite structure. Now in this diagram you can see these external walls are made up of brick. Therefore they are called as load bearing walls. And the intermediate supports are in the form of RCC column. So here in this structure, load bearing walls as well as the frame structure is used. Here the load of slab is transmitted to the subsoil by this external walls, that is the load bearing walls, and even through the intermediate, that is the column through the foundations. This type of construction is generally adopted for industrial sheds, workshop halls, and godowns. Thank you.